Dream to become the next Sir Isaac Newton or Albert Einstein?
Learn physics from Rashid Al-Bari. Let's start today's remote learning with Do Now.
Scenario number 1, you have a positive charge. Scenario number 2, you have a negative charge. Scenario number 3, you have a positive charge and you have a negative charge.
Now pause the video and try your own.
The field lines of this positive charge goes outward radially. The field lines for this negative charge goes inward radially. The field lines, it starts on positive, so this is scenario 3. It starts on positive and go to the negative. It starts on positive and go to the negative. It starts on positive and go to the negative. It starts on positive and go to the negative. Okay. Now let's go do the lesson. So what is field? We are not definitely talking about cow grazing on a field. We are talking about different type of field. So for us, a field is a capacity to do something. Capacity to do something. Capacity, or every single point has a value. In a field, every single point has a value. So what are we talking about? So let's give you an example. Let's consider your study room. So let's consider your study room. This is your study room. In your study room, what do you have? You have window, you have door, you probably have 2 windows, you probably have the radiator, you probably have the ceiling, you probably have the floor. So let's consider these points, okay, in your study room. Let's take a thermometer, okay? We're gonna call it a temperature field. Temperature field. Let's take the thermometer. What can you do with the thermometer? You can measure the temperature. If you measure the temperature over here, the temperature is in average 10 degrees Celsius today. But if you measure it over here, close to the window, it's probably gonna be 9 degrees Celsius. If you measure it close to the radiator, it's probably gonna be 11 degrees Celsius. So in average, it is 10 degrees Celsius, okay? So temperature is not uniform at every single point, but every single point has a value, okay? How many points you can have in your study room? Millions, billions, trillions, okay? So I just put some of the points just to help you understand. So a point, this is close to the window, a point, this is close to the radiator. So if you use the thermometer to measure the temperature, you get a different temperature at different point. Okay, now that's this. Every single point has a value. Now, what is this? Capacity to do something. This temperature field can do something. What can it do? If you bring a hammer from your basement and put the hammer very close to the inside your temperature field, and you observe what would be the reaction of the hammer due to sitting in this temperature field, you probably observe nothing. But if you bring ice from the kitchen and put the ice very close to the heater, what sort of a thing you expected to observe? The ice will probably melt. Okay, so capacity to do something. So this temperature field has a capacity to do something if you place something that it interacts with. You get it? Okay. Now today we're going to talk about two types of field. Gravitational field and electric field. Gravitational field was first discovered by Sir Isaac Newton, and electric field was discovered by Faraday. I give lots of credit to Sir Isaac Newton to discover the gravitational field, and I give lots of credit to Faraday to discover the electric field. Now, what are you talking about? How can we use this to understand the gravitational field? Let's understand the gravitational field. So you have Earth over here. This is the flat approximation of the Earth. Now this is the gravitational field. Okay, this is the gravitational field. Just like the temperature field, gravitational field has a capacity to do something. All right, it has a capacity to do something. How can you observe the capacity? All you need to do is bring some ice in this temperature field. Then you will be able to observe the capacity of the temperature field. How can you observe the capacity of this gravitational field? You need to place something that is interact with, and that is mass. If you put mass in the gravitational field, what the mass will do? The mass will accelerate. So the gravitational field has a capacity to do something, but you have to place something to observe this capacity. Now let's see the electric field. So you have electric field. Okay. Now this electric field has a capacity to do something. However, how can you observe this capacity? All you need to do is place a charge. If you place a charge, it will accelerate. To this direction. So capacity to do something.
Let's finish today's remote learning with an exit slip.
Okay, now I have a negative charge, and okay, so I have a negative Q. I have two positive charges. I want you to draw field lines. Okay? Alright, pause the video and try your own.
Now pause the video and try your own.
Now let's do it together. Alright, so this is double the charge than this one. And charge starts from here and ends over here. So I'm gonna have 1, 2, okay. So how many fields I have? 1, 2, 3, 4, 5, 6 fields. How many fields are I supposed to have over here? Double. Why double? Because I have double the charges. We'll continue to do the electric field tomorrow.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.